Okay, now we are moving on to the next part of this session, installation and hello world of the lingua franca. Oh, yeah, I think I did. Yeah. Yeah. Okay. So I want to introduce our teaching assistants from Arizona State University, Diksha and Daniel. They're over there. So to help you uh, with any troubleshooting during installation or running lingua franca. Yeah. So yeah, again, the tutorial materials are here, and you can just navigate here very easily by typing in lf-lang.org and click on events and lingua franca tutorials, and we have everything here. Oh, before that, actually, I just wanted to briefly mention that, add to what Edward said earlier. We have educational materials using lingua franca and Pico 2040 here. It's called Embedded Systems Labs, and these labs are used by multiple universities, including Arizona State University, UC Berkeley, and University of Manova. Yep. Okay, going back to the link of tutorial materials. Uh, if you want to install, how many of you plan to install lingua franca on your computer? Okay. Oh, okay. So does anyone want to use virtual machines? Okay. Yeah, then maybe I can focus on installation. Uh, how many of you actually already installed lingua franca?
Client version.
Okay.
It's good version.
Okay, nice. Oh, just VS Code extension? CLI. Okay. Without VS Code. Okay. So may yeah, right. Maybe
You don't get items.
yeah.
When you send that correct, you have no way max for you do those other good access. I actually decided years ago that Max is bad for your health. it, it requires key combinations that cause repetitive stress syndrome. Because of just physical reasons. Yeah, not a mental reason. Well, maybe mental reasons too. I I could give up because of mental reason. And every time I have to ask for it, it feels like it's the end of the world.
Yeah. Anyway, if you have VS Code already installed, you can simply navigate to install extensions here. Then to search for lingua franca. Yep. You can install from here. Yeah. But actually, you don't need the lingua franca extension to work on tutorial. Okay. So installation instructions are here, and we also prepare the hands-on exercises in this repo. So, how many of you already created a repo? Okay. Wow, you're really fast. It's okay. So just to repeat this. Yeah, right. Exactly. So actually, I deleted my repo just to show you how to create this from scratch. So this is how you create your own repo using this as a template, and then it should be done now and can clone it. Ah, I need to delete the older one. Should be done instantly. Yep. And you can start from the README here. Actually, I think it'll be easier to view this here. And yeah, this will walk you through series of lingua franca programs to go over or try lingua franca programming um, on the topics that Edward covered earlier. And here we use very simple scenario inspired by Edward's paper from last year. And yeah, you can start from the README again. Then yeah, I think you're already done with the installation, so you can skip here. Maybe I can briefly introduce the scenario that we'll be using for the hands-on programming session after the break. So this is a scenario: power grid as a distributed cyber physical systems, and here we have a power grid system, and we have distributed controllers in region A and region B. We in this example, actually, we call this region A California and region B as New York. And at each site, we have a power grid interface facing the, for example, human operator, and manager, grid manager, which will face the physical power grid. Yeah, we have the interface and manager here. So if you look at uh, the first program, which is under source, yeah, it's called step one after. Actually, let me close other windows. And we have, oops, oh no, it happens every time. Okay, not every time. Yeah. So these two are interfaces and these two are managers. And I believe this interface is in the same region as this manager. And if you look at the Lingua Franca program, they will show up as these two instances in the main reactor. So GI1 is the grid interface for California, and GI2 is the grid interface for New York, and GM1 is for California's grid manager, and GM2 is New York's manager. So as you can see, uh, both interfaces are connected to both manager. So um, the California's grid manager will be receiving comments from a grid interface from California, the local grid interface, and also the grid interface in New York, so which is a remote grid interface. Yep. Yeah, that's the scenario that we'll be using. And here we want these two grid these two sites will have a shared view of the grid state. And here the grid state uh, means the whether there is a excessive generation or deficit in generation. For example, if the grid state is, let's say, positive 100 megawatt, that means that there is a excess generation compared to current demand. Yeah. So, and if it's negative, that means that we generate power less than the actual demand. So we don't want to keep this grid state negative too long or below a certain threshold. Yeah. And we have two operations from the grid interface. One is dispatch up, increasing the um, amount of power generation. And we can also curtail or dispatch down the power generation. Yep. To avoid excessively generating power too much. Yeah, because the power grid has limited capacity to store power. Yeah. So this is how we balance the power supply and demand with the power grid. And there are 6 steps for you to follow. Maybe I can briefly go over the first one. So from here, you can navigate to the first step, step one, starting from the actor model. Actually, reactor model is a variant of actor model of computation. And you can actually go back to the actor version of model computation using lingua franca program um, by using something called physical connections. These are squiggly arrows here, shown here. And as opposite to what Edward described, if you use these physical connections, um, the messages on this input port will be timestamped again based on the physical time that this message was received on this end. Yeah. So yeah, this will be a demonstration of actor model computation using lingua franca. Yeah. So you can also see the code here. Let me show the code. And we have the this reactor called scripted grid interface, which takes three inputs: node name, the command value, and the command time. Yep. So uh, and we have a command timer here, which will just take this input parameter. Actually, this is not a this is different from input port. This is an input parameter that you can uh, assign when you instantiate this reactor. So this is very simple interface where you give a designated command time and the command value. It'll just send that command to both the local grid manager and the remote grid manager. And we have a simple grid manager reactor, which will take node name as a string. And this takes commands from the local and remote grid interfaces. And then it has a state variable in integer, which will represent the local view of the shared grid state that I showed you earlier, this one. And you want to here we want to keep the shared grid state close to 0, and while avoiding possible blackout by keeping this above the safe threshold. Okay, so
So,
yeah,
hoping that I point out something.
yeah.
So these, as Hogan said, these squiggly connections mean that the timestamp should be starting at the sending end, and new timestamps are assigned at the receiving. So one consequence is when one of these guys sends a message, it thinks it's sending at a certain time, but the times at the two recipients will be different. And won't even be the same at two recipients. So there's no longer any notion of processing the right same timestamp board. So you have to be very careful with what you do here in order to maintain consistency. It's no order. That's kind of the point of this first exercise.
Yeah.
It's for that.
Yep. Before we solve it using lingua franca connections. Yeah. Thank you. Yeah. Any questions so far?
So we said we don't control the times of arrivals anymore.
Right.
What will be the maximum experiment out of this question? Well, part of the point is this is what you get with lump sum or with actors. This is what you would get with Ross. Yeah, that's why we have to deal with the disparity.
Right.
So we have to monitor this.
Yeah. We are starting from intentionally. The example with the intentional flaw. Yeah.
No, not necessarily.
It's not a flaw. Yeah. It's a feature, but yeah. So at the bottom of each markdown file, we have exercises. So first, we are going. Currently, the program doesn't have the implementation of avoiding the negative grid state below threshold. So yeah, the first exercise for you is to implement the logic to reject the command, which can make the grid state below the specified threshold, which is negative 200 megawatts. Yeah, and also logging a warning instead. And as a hint, actually, throughout these multiple steps of exercises, you'll be making gradual progress. So if you take a look at the next step, you will get hints for the exercises for the previous step. Yeah. So for example, should I talk about this or?
I think we should go to the break.
Oh, okay, okay, yeah.
Don't give them too many.
Okay. Yeah. Okay. So I'll let you play with Lingua Franca program, and we'll come back here in at 4:30.
Negative or just go? You have to prevent that.
Yeah, we have to prevent it. Prevent the grid manager updating the grid state. Yes. Yes. Yeah. Okay. Yep. Thank you. Yeah. And we'll meet again at 4:30. And please let us if you know if you have any questions.